Okay, we're starting weird math today, algebraic proofs. So this is a little more normal because you guys know how to solve equations. And so I like to start with this today because it kind of shows you the process of proofs with something you're familiar with. You're going to be given 10 reasons today. You're going to be given more tomorrow. And basically what this is, you're going to be given the question and you're also going to be given the answer. And for every step in between, you have to give a reason of what you're doing to get to the answer, what you're doing to solve. These first 4 steps, you're not going to use a ton. You're going to use this one today, the symmetric property. But these 3 right here, I'm just going to talk about them so that tomorrow's not the first time you see them. And then especially these 2, you're going to use them a ton this unit. But I just want you to have an idea of what they are. So the reflexive property, you're honestly not going to use it till unit 5, but I want you to know what it is about. It's basically the 2 sides mirror each other. So if it's the exact same thing on both sides. So all these are in conditional statements. So if A equals A, then A equals A. All right. Well, that's reflexive property. It's the exact same on both sides. It doesn't change. The nice thing about this symmetric property is it's easy to remember because, see, there's an S there, and then S there, and S there. So symmetric property means switch the sides. The S's go together. That's nice. So if you start, in a lot of, I think of it as something like, maybe this is what you're more used to seeing. If A equals 9, so it's like having a step where they're switched around, where it's 9 equals A, but your answer says to prove that A equals 9. So you have to say that symmetric property is where you're switching the sides, which you might look at that and be like, that's silly. I know that you can do that. Yes, a lot of this is, yes, you know that you can do this, and you're going to want to put 2 steps in one, but you can't do that. You have to tell each individual step what's going on. Transitive property. All right. You're going to hear me say this a lot over the next few days. If 2 things are equal to one thing, or then they are equal to each other. Or if 2 things are equal to the same thing, then they're equal to each other. Like those things, I'm going to say that a lot. So notice A and C are both equal to B. Therefore, A and C are going to equal each other. And this is how I usually circle the things that are the same and underline the things that are going to equal each other. So if A equals B and you know that B equals C, well, then we know that A has to equal a C. Because if you throw a number in there, let's say 7. So if A and C both equal 7, then they equal the same thing. That's what the transitive property is. Substitution is similar to the transitive property, but the difference is you are just substituting part of one side of the equation. So it's basically like, you know that A plus B equals C, but also you know B is Y. So just, you can throw Y in there for B, and that would be substituting. You're not taking 2 halves of an equation and setting them equal. You're instead just plugging in part of one of the equations. Okay, those things you're not going to see a ton of today, except symmetric property you will see. This is the bulk of what we're going to actually talk about today. Adding both sides of the equation. That's the addition property. Notice addition, subtraction, multiplication, division. They're all both sides of the equation. So what's happening here? We are A minus 7 equals 2. Well, if I add 7 on both sides of that equal sign, I know that A equals 9. So that's why it's addition property. All right? Subtracting. If I subtract 7 on both sides of the equal sign, I know it's subtraction property of equality because you're subtracting on both sides. Multiplication. Oh, we've got a fraction here, but all of a sudden, we no longer have a fraction. How do you get rid of that fraction? You multiply by 2 on both sides of the equation to get A equals 14. All right, and then division is dividing on both sides of the equation. So divide by 2 here, divide by 2 here, you end up with A equals 4. So this is a lot of stuff that you typically do in your head. It's pretty easy, but you're going to have to just say what you're doing and write it out. And that's why we've been doing a lot of things where, like on the patterns, you would write out what is the pattern. So you're used to writing out your steps. All right, these last 2, these are both done on one side of the equation. So that's the main difference between these 4 and these 2. Distributive property. You guys know what distributive property is. You typically can identify it. Just make sure you realize that it is distributive property. It's not multiplication property, because that's multiplying on both sides of the equation. Distributing is distributing that 2 into those parentheses. But you're multiplying, but just on one side of the equation. And then this last one, combining like terms or simplify it. You will see it either way. They're interchangeable. But it's basically adding or subtracting, whatever you're doing, putting terms together, but just on one side of the equation. All right, let's turn the page. All right, we're going to do this first one together. There are 10 of these problems. There's a lot of the same ones over and over again. So don't think, oh, I learned 10 properties. I'm going to put the 10 properties here. No, you don't use all the properties. It's just random questions. We're going to do number 1 together. So notice you have this. AB plus BC equals DE plus BC. It's kind of complicated looking. But then all of a sudden, something's gone. So you look, oh, I end up with this. What disappears? You guys identify? BC is gone, right? No longer exists. How do we get rid of BC? Well, it's on both sides, and it's added. So the way to do that is subtract. So does this look different than when you are subtracting for an algebraic problem? Absolutely, it looks different. But you're still subtracting on both sides. So it's the subtraction property of equality, but I'm lazy, and I'm just going to write POE because I don't want to write out property of equality. So what you're going to do is I'm going to pause this, and I want you to solve all of these and then check with me what your answers are. I will be explaining more of these tomorrow, so if some of these you're kind of fuzzy on, that's okay. Today was really just meant to be like an intro day, so you see these for the first time, and then we'll discuss them more tomorrow. Like this first one is the reflexive property. You could have written property, I just am lazy and didn't. But it's the reflexive property, same exact thing on both sides. This one's going to be transitive. Why is it transitive? Because two things that equal the same thing equal each other. So that's the transitive. They equal the same thing. Both of them equal xy. Therefore, they equal each other. This one is multiplication because you have a fraction and then all of a sudden the fraction disappears. How do you do that? You multiply on both sides by the denominator. These next two are division because you're dividing. I know they both, they look a little bit different because this ends up with a fraction. This ends up with a whole number, but you're still dividing. This one, just make sure you know this one for today. You will have to know this one today. This symmetric property. So symmetric switches. Symmetric property, it's not the property of equality, I don't think. Well, actually, I don't remember. It's just this symmetric property. I shouldn't write that. I'm just going to write symmetric. It's not really that big of a deal, but the only ones that are property of equality are the multiplication, division, subtraction, addition, because you're doing that on both sides of the equation. All right, and then these next two are both transitive properties. If you put substitution for one of them, it's okay. We're going to talk about that a ton over the next few days. But both of these things, you're taking two halves of an equation and setting them equal to each other. So it's the transitive property because it's two sides of an equation equal the exact same thing. Therefore, it equals each other. Transitive property is almost like it's very similar to substitution. But you're taking two sides of an equation, setting them equal to each other. This last one is addition, property of equality. So after these two doozies, this one was probably a lot easier to notice. Oh, I'm just adding 7. All right, for this next one, I'm going to solve this one for you. So I'm going to go through this process. You're basically just going to be watching me, but pay attention to the process and how this works. And then the next page is going to be a chance for you guys to show me if you understand. All right. Write an algebraic proof, justify every step. All right, the first step is always the given. So this given won't always be filled in. You'll have to write that given in there. But notice the given is just copied right there. All right. And then what's happening is you're trying to determine, okay, what happens in this step to get to here? So what happens from here to here? And that's what we write here. A lot of times people want to write the step on like the wrong box. They want to write it one step up. But what you're doing is you're distributing in this box and you're like, okay, so this is happening. I'm going to multiply by -4 on both of these. And then I'm going to end up with this. So where do you write that? You write that next to like the final answer. So your question is always, how do I get to this step? Oh, I distributed. But it's the distributive property. All right. So you can write property if you want, or just distributive, any of that. And then how do I get from here to here? Okay, what is happening? Well, the 12 is disappearing. Something is happening to that 12. But do you see why people want to put addition right here? Because that's kind of what you're doing in this box. But it's actually, you write that down here because, oh, how do I get from here to here? Oh, I add. Addition, property of equality. And then from here to here, all right, I need to get rid of that -4. Divide by -4 on both sides. That's going to be division. So I put that little arrow. You don't have to put the arrow. It just is a helpful reminder. And then your last step. I want x to be on the left-hand side because what am I trying to prove? I'm trying to prove that x equals negative 13, not negative 13 equals x. Seems like a silly step, but it is something that you will have to prove. So that is the symmetric property, which, you know what, it's actually kind of a nice problem to have because it's a really easy one to identify, and it's just easy points. All right, we're going to turn the page. And what's going to happen is you are going to work on this problem. If you are done with this problem before I go over it, work on the next one as well. So you're going to work on both of these problems. You may not get through both of them by the time I go over it, but I want you to work on this and see if you can kind of follow the process that I just showed you. Okay, so if these sides filled in, your first step, you are distributing here to get to this step. So remember, that's what you ask yourself. All right, how do I get to here? Oh, I distributed to get to here. So that's what goes in that box. And then what do I do here to get to here? I'm subtracting 5 on both sides. So that's subtraction property of equality. And then the last one is division because you're dividing by negative 20. Hopefully this one was pretty straightforward. If it wasn't, maybe you just made a mistake on this side and that can throw you off. But let's look at this next one. This one is the one that can be a little trickier. So notice the boxes. So on here, make sure you're not putting addition in this because you are only adding on one side of the equation. So if you put addition, it's a common mistake, but you are combining like terms from here to here. So you should end up with this on the second step no matter what. Then there's some variations of what you can have. Some people that I have noticed, they're subtracting in the same step. So they're doing both of these at the same time and just putting subtraction property once. But you can't do that. You have to show each step what's happening. So I subtracted 6 first, then I subtracted 1, then I ended up with this. I divided by negative 2, and I get x equals 4. There are other ways to solve this problem. These can be flipped, but the only way to solve it with this number of boxes is to end up like this, like 2 subtractions and a division. Because if you end up subtracting the 4x and adding the 7, you would have to add in a symmetric property to flip the x's around, which is not a big deal. But you may not have noticed that that needs to happen.